Hello students. So after completing the first problem on higher order differential equation when RHS is exponential function, let's move to the problem number 2 where we'll see one more numerical and we are going to find out the solution of that by using the rules of higher order differential equation when RHS is exponential function. So here we have to solve d square x by dt square minus 2 dx by dt minus 3x equal to e to the power 3t, and it is given that x is 1, dx by dt is 2 at t equal to 0. So guys, to solve this differential equation, or I would say higher order differential equation, just observe the right hand side, and that is the exponential function. So guys, I am going to solve this problem by the method of higher order differential equation when right hand side is e to the power x or e to the power 8t, because here the independent variable is t. Now to get the solution we are going to follow a few steps. So in the step number 1 we will find the complementary function. Now guys, to get the complementary function here, if you observe, then the dependent variable is x and the independent variable is t. So in this case our complementary solution would be xc and not yc. So generally we take complementary solution as yc and the particular integral as yp, because we say that, or because we have the given equation as dy by dx. So there we have the dependent variable as y and independent as x, but since in our case dependent is x, we'll find out xc. Now to get that complementary function, first of all we need to find out the auxiliary equation, and for that we will replace these differential terms by the operator d. So guys, here we'll rewrite this as now we can take x common, so we will get, now this is the value of function of d and this is required to find out the auxiliary equation. So we'll equate it to 0 to get the auxiliary equation. Now guys, let's find out the factors of this so that we can get the complementary function. So the factors of -3 are -3 and +1. So here we'll say therefore this is d minus 3 into d plus 1 equal to 0. So therefore we'll get value of d as 3 and -1. Now we'll find out the complementary function from these roots, and if you observe the roots, these are the real and distinct roots. So guys, we know the formula to find out the complementary function if the roots are real and distinct. So whatever are the roots, that becomes the power of the e. So here I'll say the complementary function, which is xc, is c1 e to the power 3t plus c2 e to the power minus t. Now guys, observe one more thing, that here I am writing this power in terms of t, and the reason is, if you observe here, then the independent variable is t. So whatever is the independent variable, that we have to carry over here. So in the previous example we were having dy by dx term here, and y was dependent and x was independent. That is why we were writing x here and y here. Similarly, now I'll write x and t, because here x is dependent, t is independent. Now after finding the complementary function, let's move to the particular integral. So that is given by the formula 1 upon function of d. Now here the function of d is d square minus 2d minus 3, and here we multiply it with the right hand side. So right hand side is e to the power 3t. Now guys, to get the answer, we will put this 3 here as it is as per the rule. So whatever is the value of a in the exponential function, we put that value of a in f of d. So we'll replace, or we'll substitute d as a. So here a is 3, we'll get d as 3. So 3 square will be 9, minus 2 into 3 is 6, that is -6, and then -3. So guys, 9 minus 6 is 3 and 3 minus 3 is 0. So we are getting denominator as 0. And whenever we get denominator as 0, we reject that answer. So what do we do? So in that case, we have to find out the derivative of that f of d. So guys, here I'll find out the derivative of f of d. And with that, we also write one extra term in the numerator. And that extra term, in the previous example, we have seen it was x, because there the independent variable was x, but in our case the independent variable is t, so here I'll write t upon, now derivative of this is 2d minus 2 and into e to the power 3t. So guys, by solving this we'll get 3 2s are 6 minus 2 4, so t e to the power 3t upon 4. So this is the value of xp. Now we got complementary function, we got particular integral. Let's find out the final solution. So therefore the final solution x is so guys, here we got the final solution. But we are not gonna stop over here, because if you see the question, then in the question we have few conditions. So I'm gonna use these conditions in this result. So guys, let's call this as equation number 1. Now if you see the condition here, it is given that at t equal to 0, the value of x is 1 and the value of dx by dt is 2. Now guys, we have x over here and we have t also. So in this equation I can put the value of t at 0 and x equal to 1. But guys, we don't have dx by dt. So to put value of dx by dt as 2, we have to differentiate this equation number 1 with respect to t. So by doing that, we will get dx by dt equal to, so the derivative of e to the power 3t is 3 e to the power 3t. So derivative of this is negative e to the power minus t. Then here 1 by 4 as it is. And in the bracket, we'll apply the u rule or the product rule of derivative. So u, that is t as it is. Derivative of e to the power 3t is 3 e to the power 3t plus e to the power 3t as it is. And the derivative of t is 1. So guys, this is equation number 2. So we got two equations, we have given condition. Let's put those conditions over here to get the final answer. So accordingly, we'll put t0 and x1 in equation number 1. So here I'll say at t0 x is 1, and therefore from equation number 1 we'll get x is 1, so 1 equal to t0, so e to the power 0 is 1, so here I'll get c1, e to the power 0 1, so here I'll get c2, so c1 plus c2. Next t0, so this whole term will become 0 because here we have 0. So guys, this is equation number 3. So here we got the equation in terms of c1 and c2. Now let's see the second condition, and by that we'll get one more equation in terms of c1 and c2, and then we'll solve these two equations simultaneously to get the value of c1 and c2. So the second condition is the value of dx by dt is 2 at t equal to 0. Now guys, let's come here. So I'll write that condition here. So the value of dx by dt is 2. So therefore 2 equal to, next t is 0. So this will become e to the power 0, which is 1. So this is 3c1 minus, this is c2, e to the power 0 is 1. So that will become c2 plus 1 upon 4. Now guys, here t is 0. So this term will become 0, e to the power 0 is 1, so here I'll get 1, so that is 1 by 4. Let's shift this 1 by 4 on the other side, so 2 minus 1 by 4 is 7 upon 4, so here I'll get 7 upon 4 is 3c1 minus c2, equation number 4. And now guys, we are going to solve equation number 3 and 4, so you may use calculator to solve it, but here I'll do it manually because That's a simple linear equation. So here I'll add 3 and 4 so that C2 will be cancelled, because here C2 is positive and here C2 is negative. So we'll add 3 and 4. So by adding 3 and 4, here we'll get 1 plus 7 by 4. So therefore 11 by 4 equal to, and 3C1 plus this C1, that is 4 times C1. So here now to get the answer, we'll shift this 4 in the denominator and that will become 11 upon 16. So guys, here therefore we will say value of C1 is 11 upon 16. Now let's find out C2 by substituting this value in equation number 3. So we will get therefore 1 equal to 11 upon 16 plus C2. This will go there. 1 minus 11 upon 16 is 5 by 16, and therefore C2 is 5 upon 16. So guys, here we got the value of C1 and C2. Let's put these two values in equation number 1, because guys, equation number 1 is our actual complete solution in which C1 and C2 are unknown. Now we got the value of C1 and C2. I'll put it here so that we will get the final. And guys, this is the solution of given differential equation. So I'm sure that you understood how I applied the method on this numerical to get the final answer. And guys, if you want to learn such more videos, then do subscribe to Ekeeda channel, because here you can get the updates about the new videos which we are posting every day, and you can get whole knowledge of engineering and the other subjects of science. And don't forget to share this video with your friends, because friends also need this video since they are also studying with you in engineering or in science field, so that they can get the knowledge and they can also get the good marks like you. So thank you for watching. In the next video we are gonna cover few more numericals on higher order differential equation. Thank you very much.